everyone, my name is Aarohi and welcome to my channel. So guys, in this video I'll show you how to use key point detection on your custom dataset, right? So the key point detection which is available in Detectron. So in my last video I have explained you, I have shown you the practical implementation of pre-trained models of Detectron, and Detectron is a library developed by Facebook, right? And using that library we can perform various functionalities. I have discussed that in my previous video. So if you want to know about that, if you want to learn what is Detectron and how Detectron work, then you can check the video. The link is given in description section. So today we are going to focus on key point detection on custom dataset, and we are using that key point detector which is present in Detectron. Okay, so you can see this output over here. This is the output we are getting from the pre-trained model which is present in Detectron. Okay, now let me show you another picture here. Check this picture also. We are performing key point detection using Detectron2 over here also, and you can see here that it is not working on our hand. It is not detecting key points from my hand, right? So why it is not detecting hand? Because the key point detector model, the pre-trained model, key point detection model which is present in Detectron2, that model is trained on different body parts which doesn't include hand. Let me show you what all parts are included in it, key points are included in it. So we can see here. So that key point detection model is trained on one class only, which is a person class. Means if you want to detect, if you want to perform key point detection on a person class, then you can use the pre-trained key detection model which is present in Detectron2. But if you want to do key point detection on any other custom class, then you have to train your model yourself. Okay, so in my today's class I'll show you that only. But before moving to that part, I just want to explain you few things so that you will feel easy when I'll show you the custom code. Okay, so you can see here this pre-trained model is trained on only one class, and these are the different key points it trained on. So it will detect the key point nose, left eye, right eye, left ear, and these are the other things. So these are 17 different key points. So in this particular example we can see we can say that these are the 17 different body parts for I'm referring to the 17 different body parts by these key points. Okay, so and below that you can see this skeleton, and you can see over here we have data in the form of pair. So what this pair is basically, so over here basically what we are showing is these are the key point connections. So for example, this first 16 and this 14 simply means left ankle. This 16 is left ankle and this 14 is left knee, and this left ankle is connected with left knee key point. So this is and one more thing, I hope you are clear, like this is the pre-trained model trained on this data, and the that pre-trained model has 17 key points, and these are the different connections between those key points. So now why I have shown you this particular JSON file format? Because whenever you want to work on your custom dataset for this particular key point detection, so Detectron2 will accept the data, the annotations. Your dataset should be in the format of COCO dataset, and this is the format of COCO dataset. Means obviously whenever you want to build your custom custom key point detector, the very first thing is to prepare your data, and our dataset should be in this format. Okay, now in my today's class what we are going to do is, as I've just shown you that it is not detecting our hand, so in my today's class I will build a custom key point detector which will detect the key points of hands, right? So the hand, we will prepare a data set. The first step is preparing a data set. I will show you how to prepare a data set for key point detection for hand, right? This is the first step, and then we'll train our model for this hand class, and then we'll test our model. This is what we are going to do in our today's class. So let's begin with the data set. Let me show you the data set which I'm using. So this human hand project, so this is the folder in which I have my data set. When you'll open this folder, I have one IMG folder. In this IMG folder, these are the different images on which I'm training my algorithm. So guys, this data set is very small. Again, we are not going to get good results, but obviously you'll understand the concept how to use it. Okay, so we have total 41 images, and you can see, let me open an image, and you can see like in every image we have hands, right? So what you have to do is, now what I have done is I have prepared the different key points which will show us the shape of hand, right? So these are the different images I have used. All right, so these are my images. When you'll come out from this IMG folder, over here I have train, val and test JSON file. This train JSON file will be, I'll use this file to train my algorithm, and will evaluate our model on validation, and then we'll test it on our test data set. Okay, so let me open this train.json file and show you. When you see this file, you can see for every image you will have an ID, name. This is again ID. Again, what I mean to say is, why I'm showing you this file is, our main goal is that your file, okay guys, give me a minute please. Okay, so basically this kind of data you will, this is basically a COCO dataset format. In this format, this kind of data you needed to train your model. If your dataset is in this format, then only your algorithm will train on it. So that means you have to prepare your dataset in the form of COCO dataset. Okay, so I have prepared all those files. Now see guys, how you can prepare these custom files. Now how can you prepare this custom on your custom dataset? You can prepare the dataset, their annotation files, using different tools. There are various tools available. Using those tools you can directly, you just upload these images in those tools, and they provide they provide different ways to annotate your images, and using some of the tools are there. Using those tools you can directly prepare your dataset in the format of COCO format, right? So using those tools you can get these kind of files. Now my dataset is ready. Now I'll show you how to train it, right? Okay, so now the TensorFlow version which I'm using is 2.6.0, and the Python version I'm using is 3.8.7, and this PyYAML version is required, right? So if you'll check, okay, if you'll check the Detectron GitHub, over there they have mentioned that we need this. Okay, you can go to the installation instructions. When you'll go on installation instructions from here, and over there they have mentioned, okay, so where is it? Okay, maybe they have mentioned it in their Google Colab notebook. So there they have mentioned that we need this version of PyYAML, so that's why I've installed that particular version. You can see, right? So this is the Colab notebook by this Facebook. So they have told to install this particular version, so that's why I have installed that particular version. And the PyTorch version I'm using is 1.8.0, and I'm working on CPU. Okay, so guys, these are the few packages I have installed, and I was facing some issues, so I have installed some of the packages and I've uninstalled few. So I have just commented out, so in case if you face any issues, so you can try working with these different packages. Okay, all right. After that, whenever you want to use Detectron2 library, first of all you need to build that, right? So for building that you can use this command. Okay, so if you'll check the installation page of provided by this Facebook, let me go back to the installation page. So if you'll see this installation guide at the very beginning, so they have shown the different ways to build your project, right? Detectron. So I have used the first one. So I have built the Detectron using this way, but you can use this way also, right? So I have built the Detectron. Now after building a Detectron, now I want to run on my custom dataset. So first of all, I have imported all the required modules. Once you import all the required modules, the next step is to register your dataset, right? So I have already annotated my dataset in the format of Cocoa dataset format. So I can directly register my dataset calling this function, right? So this function is already available in Detectron. Using this function, we can register our dataset in our Detectron. Then only Detectron will get to know like on which dataset we are working, right? So whenever you are working on custom dataset, you need to perform this functionality. You have to register your dataset. So when your dataset in the format of Cocoa format, then we can directly call this function. And if your dataset is let's say if your dataset is in different format, then you have to write a function for it. So guys, what kind of function you have to write for it? So for that, you can see my previous video where I have shown you how to use maskr CNN using Detectron. Over there I have explained you, over there I have created that function, right? So similar kind of function you need over here. But over here what I'm doing is, so I have already prepared my dataset in the format of Cocoa dataset format. So I'm registering my dataset like this, calling this method and this hands train. So this is the name I want to use for registering my dataset. And after that, this, so guys, remember I have one folder with the name of human hand project, right, in which I have my dataset human hand project. So this is the folder. In this folder I have my train.json file. Okay, so that's what I'm writing over here. And over here, this third parameter, what parameter is this? Over here you need to give the path of your image directory where your images are present, right? So this is the folder in which my images are present. So that's what I've written over here. And in the same way now, so in this line I have registered the dataset for training, right? Now if you want to perform testing, then you have to register your test dataset also. So for that I have written this line. Okay, now my dataset is registered. Next thing is, so guys, when I have created this dataset, then I have used 10 key points. Okay, so to define this hand, I have used 10 key points. Roughly, I'm just telling you roughly, like this is one key point, this is second key point, third, fourth, fifth, sixth, seventh, 8, 9 and 10, right? So I have used 10 key points. So that's why I have given these name to those 10 key points. A simply means key point 1, B means key point 2, and C means 3, and so on. And this J means key point number 10, right? So these are the different 10 key point names I'm using. So if you are using 20 key points to annotate your data, then you have to write the name of those 10 key points over here. Okay, and in next variable, this is basically a connection between every two key points. So remember, in Cocoa dataset format, in the very beginning of our today's class, I've told you that this 16 and 14 simply means left ankle and left ankle and left knee, so they are connected, right? So in the same way, we also have to show the connections. So that's why, okay, so that's why I'm writing connection between A and B. So these are connected, and then I'm writing connection between C and D. These two things are connected. E and F, like this is how I've created the connections, right? So you have to do these things. After that, now we have one class, right? So we are working on hand class. So you have to register that class name also. So what we are doing is we are importing the metadata catalog. This is very important thing, right? Now metadata catalog dot get, what is this hand string? Remember, in my above cell I have registered my training data with this name. So we are using this training, the name which we are using over here while registering my training data, that name you have to use over here. Dot thing underscore classes equals to hand. So what I'm saying is that my dataset have this class, my training dataset, which is registered with this name, have one class, and then I'm printing it, and you can see it is showing that we have this class. Okay, so in the same way, guys, this cell is important. All the changes which are required I've mentioned over here, right? So what all things we have to provide to this metadata catalog? One is thing classes. This I've already shown you that this is my hand, and then you have to give this. If you're working on in my case I have only one class, so I have written this. So but if you're working on multiple classes, then you can simply put commas and write about those classes. Okay, and then we are providing key point names. We are providing key point names to metadata catalog. Which key point names we are providing? Which are present in this particular variable. What is there in this variable? The names of my 10 key points which we have generated. Our data set have 10 key points. So we are telling that metadata catalog that we are having 10 key points in a data set now. And in the same way we are providing this, and evaluator type is Cocoa, and that's it. So these are the few important things we have given. Now, okay, so this step is just optional. I just wanted to see how, whether my data is properly whether I have assigned the data properly or not. So that's why I have used this particular line. This will show me the detail of my data set. Okay, so you can see my data set is in the format. So guys, right, let me tell you one thing. So see, this is the format of Cocoa dataset. First of all, file name, height and width, image ID, and annotation detail, bounding box detail, and these are the different key points for every image. So in my dataset I have around, I guess, 40 images, but some of the images are used for training and some images are used for test and validation. So we have 33 images for training. So these are the annotation details of those 33 images, right? And then let's see if our dataset is annotated properly or not. So you can see over here, you can see that I'm showing you. So these are the different images where I have annotated the hand. So you can see the different key points. This is one key point, second key point, third, fourth. In the same way, I have 10 different dots. 10 different dots means 10 different key points I have assigned in every image, right? And so my data set is properly annotated, you can see. So that's why we can see the results like this. Okay, so this is how I have annotated my images, and my data set is properly annotated, and I've uploaded the data properly. So now the next step is, okay, training. The next step is training. So why I have commented it out? Because I have already performed the training. So so that's why I have let me do it like this. So this is my training process. What all changes are required? First change is this: we want to train our data. On which data set we want to train our data? We have registered one function with this name. On this data we want to train our algorithm, and this for what is the test data. So you can, if you want, you can write like this, but I'm just keeping it blank for now. And after that, I have trained my algorithm for 2000 epochs, right? So generally just start with 300 epochs and 500 epochs. If you are getting good results, then there is no need to train your algorithm for so many epochs, right? So but in my case I was not getting good results, so I have trained for 2000 epochs, but again I was not getting that much good results. So just see, first of all, increase your data set whenever you want to work. So you should have more data, or you can use data augmentation to increase your data. So in my case I'm just using 33 images to train my algorithm, and I have trained my algorithm for 2000 epochs, but still I'm not getting good results. And the image size is 128 I'm using. By default the image size is 512, so if you'll not give any size over here, it will take 512. So you can use 128 or 256, you can choose as per your requirement. So I have reduced the size so that process will complete soon, so right. So number of classes are 1, so you have to do the change over here. Let's say if you are working on multiple classes, if you are working on 5 classes, then you have to define 5 over here, 5 over here. And this is related to key points. You have to tell like how many key points are there in your data set. So our data set have 10 key points, so I've written this. And this point is again important over here. You have to write 10. Just copy this code as it is, just change these. 10 is the number of key point, just change as per your dataset requirement, and then it will start the training. Okay, so once your algorithm get trained, you will get this output folder, right? This folder will get created itself, and when training will get completed, you will get these 2 different files over here. This metrics file is having storing all the losses, like how much class loss is there, key point loss, these kind of things are storing in it. And this is our final model. Now using this model we will test our algorithm. Okay, so now we have our model. Now let's test our algorithm. So for testing our algorithm, what you need to do is, see, I'm loading that trained model which I have just trained. I'm loading that model, and then we are calling default predictor over here, right? And then I'm providing the image to it on which I want to work. So I want to perform the testing, I want to do the key point detection on this particular image. So using this predictor I am performing the testing on it. And after that, so guys, now this is the code. Why I have written this code? Because while working on it, my algorithm was detecting the pre-trained classes of Coco dataset, those 81 classes, right? But what I want is that my algorithm should detect the hand. So that code is just to get the single class. Okay, and you can see over here it is detecting the results, and you can see it is only detecting the hand class. And you can see this image is a very low resolution image, so that's why we cannot see clearly. But if you'll see here, you can see the pink dot over here, the green dot over here, right? So these are the different key point detection results from my algorithm, but you can see that our algorithm is showing that the hand is over here also, over here also, and here also. So why we are getting such bad results? Because we are training our algorithm on only 33 images and our algorithm is giving us very poor result. But you can see that our algorithm is working, we are getting results, but it is detecting key points, but it is not detecting all the key points. So one key point it is detecting from here and other key point it is detecting over here. So in my case, how I can improve the results? I have to increase the number of images first of all, and then after increasing the number of images I can see if I'm getting good results. Otherwise I'll increase the number of epochs, and obviously then I'll get the good results. So this is how you can perform this key point detection on your custom dataset. So guys, I'll share this code in my GitHub repo and the link is given in description section, right? Try this code and I hope you like my video. Thank you for watching.